Hello. Let's see how we can spin a cube using BlocksCAD at BlocksCAD3D.com. It is a visual programming environment for solid modeling. It is built on the open source Openscad. If you like programming, writing codes for solid construction, you might want to give it a try at openscad.org. But for beginners and children, a visual introduction could be useful. So here we are going to use a few lines, a few blocks to spin the cube and ultimately generate an STL file which can be printed. But before we get started, let's introduce one important idea in mathematics: a vector. A vector is simply a directed segment. In a 2D space, a vector can be defined by 2 points. For example, from C to D, we have a vector. It can be labeled as V. Indeed, the initial position of a vector does not matter at all. From C to D, we are going 1, 2, 3 units to the right and 2 units up. The same vector can be represented, or the idea can be represented by AB, where A is at 0, 0, the origin of the Cartesian system. From 0, 0 to 3, 2, we are doing the same thing. Therefore, C, D, AB, these two vectors are exactly the same. It does not matter at all how and where you put a vector. For simplicity, in most cases, we are going to drag the starting point to the origin, like A. And that way, we always start from the origin, 0, 0. And we can use the coordinates of the endpoint, in our case 3, 2, as a vector. Okay, just a way to talk about the big ideas behind a vector. So I'm using GeoGebra to generate these basic examples. So a vector V, in this case, you see it? Even if you define it as going from C to D, GeoGebra represents that as a vector that has 2 numbers, 3, 2. And this is a vector. 3 really means you're going 3 units to the right. 2 really means you're going 2 steps up. Does that make sense? So a vector can be represented by 2 numbers. Well, we assume that the starting point is at the origin. All right? And the vectors can be used to translate objects in a 2D space. For example, here I have a pentagon, which can be translated along this vector. U is defined as 3, 2, right? 3 units to the right, 2 units up. So everything on this pentagon is pushed 2 units up and 3 units to the right. So this poly 1 prime, this pink one, is the translated pentagon. We can also define vectors in a 3D space using 3 numbers, or 3 coordinates if you like. Again, the location of the vector does not matter at all. So the only 2 things that are important is 1, the direction, 2, the length of the vector. So for simplicity, we always start from the origin. Okay, so we now have, so this vector U is 1, 2, 3, written as a column. 1 really means we are moving 1 unit along the x-axis, the red one. 2 units along the y-axis, and 3 units along the z-axis. Okay, so it's a way to talk about moving things around in a 3D space. Of course, you can define vectors in a 4D, 5D, or ND space using the corresponding number of coordinates. Vectors can be used in a 3D space for translation too. For example, I have a cube defined here, and it can be translated to this new location up there along this vector. So everything on and within the cube is translated 1 unit along the x-axis, 2 units along the y-axis, and 3 units up along the z-axis. So that's the basic idea of a vector. In textbooks and publications, there are many types of notations for the concept of vector. It has multiple notations. It really depends on the context and the author's preferences. And so as long as we understand the idea, and it really does not matter at all. For example, a vector from the origin to a point in the 3D space 5, 5, 5 can be written among many other formats as, OA with a arrow, meaning we are going from the origin to the point A. It can be a lowercase letter with a dot at the top, and we assume the vector starts from the origin. It can be a bold lowercase letter, and it can be written as a column like this, or a row, depending on the context and our purpose. And in Openscad, for example, it uses a row format with actual brackets. So whether you use brackets, these squared parentheses, or regular parentheses, it's really up to your publisher or your preference, right? So indeed, and the rows by any other name would smell just as sweet, right? As long as we understand what it means. All right, that's a brief introduction to the idea of a vector. And the reason we want to talk about a vector is in Openscad and indeed in BlocksCAD, we occasionally need to mention the idea, use the idea of a vector. All right, let's go back to Openscad. Not Openscad, BlocksCAD. So I have this ready-made. Let's go back to the beginning so I can show the basic ideas. I'm going to relaunch the browser. All right, that's the front page of BlocksCAD3D.com. You can create an account if you like, or you can just find this button, create now, and open a environment. So I have all these things defined. I assume that it remembers I'm going to just drag them out of the window, meaning you are deleting them. All right, so I have nothing here. I have the 3D space here, and on the left I have all these commands color coded. So I need a cube. All right, let's go. There are many ways, there are at least 2 ways to create a cube. You can start with a square and then extrude it, or you can just go and find the cube command. So we have a cube command here. So just drag it to your work place. This is a coding place, right? So we have a cube there. And X, Y, Z really means the 3 dimensions of the cube, 10 by 10 by 10, as you can see. Let's create a 50 millimeters. The unit is millimeter by default. 50 millimeter and 50 millimeter cube. Okay. And centered, not centered. Do you want the cube to be centered at the origin? And for our purpose, let's not center that. All right, so this is one block which corresponds to a line of code in Openscad. If you really want to look at the code behind it, look to the upper right corner and find the word code. You can see it's just one line. Cube, there's the vector. This vector is used to specify the dimensions of the cube. 50, 50, 50, right? Center equals false, which means we are not centering the cube. All right, let's go back to blocks. So once you have a line of code there, you can render that, create the corresponding 3D solid. Look down and find the command render. So now we have a cube there. That's you can zoom in and zoom out using your mouse. I'm press and hold the left button on your mouse. You can rotate the cube, the big cube, right? Change your perspective. So that's a cube. So we are going to rotate this cube along in a major or long diagonal from the origin. How about to that point? So if you so that's 0, 0, and this is 50, up 50, and if you look at the y coordinate of this point is actually 50 also. So because this is a cube. So if you imagine a vector, a line connecting the origin to this point, right? And the vertex that's really, really far from the origin. So that can be described using a vector in BlocksCAD or Openscad. All right, we need that in a moment. So the reason we use a vector because Openscad uses it as a vector. All right, so let's rotate this cube around that vector. It's a 50, 50, 50. All right, good. Let's go to feel free to play around and find the commands. Initially it can be confusing. Go to transform. There are many commands you can translate. You can rotate by certain angles. That's not what we need at this moment. There's a block called fancy rotate. Oh, that's a fancy name, right? Fancy rotate. It really means you rotate an object around a vector, right? So see, yeah, we have a prompt there. It rotates one or more objects around the vector from the origin to the point x, y, z. Right. We know what we need. Let's drag this block to our workspace. All right. So we first the green line block defines a cube, and we want to have this cube rotated by this command, this block. Rotate. How many degrees? Right now 0 degrees. Well, let's try. Yeah, you have this like a protractor there. 60 degrees. Right. You can change that later. Around what? This is a vector. Okay. Right now it means nothing, and so it's 0, 0, 0. So it's the 0 vector, and we don't know the direction. Its length is 0. So we know what we need. When this point has a coordinate, yeah, 3 coordinates, right? It's 50, 50, 50. So we'll put a 50 there, 50 here, and 50 there, defining a vector around which we're going to rotate the cube. Does that make sense? All right, let's see what happens if we render that. By the way, if you want to change the color of your model, you can just click this button, and how about pink? All right, if you like it. So we have a cube here, and we are going to rotate it. We're going to rotate this cube. Here we go. Okay, is that interesting? Now, that's only one cube rotated. To really model the consequence of rotating or spinning a cube, we need multiple cubes overlapping with each other in space. That, of course, you can do it one by one, create many cubes. For example, you can I copy and paste these blocks? I think I can. Copy and paste. Yeah. But the upper one creates a cube which is rotated 60 degrees. For the next one, I'm going to try. How about you can just type? I think you can just type 120 degrees. Press enter. Let's see what happens. So these two modules create two cubes. Render them. See, we now have two cubes, right? And of course, you can add more and more, creating numerous cubes overlapping space, just for the fun of it. Let's copy and paste again and do another one. This time, how about 120, 180 degrees? Or you can try 45. So now we have three cubes, right? We should have three. One. Now. And you can add more and more. Well, there's another way to do this kind of iterative modeling. We use a loop. Let's delete, just throw away these blocks we don't need. Let's go and find a loop. There's a math, there's a logic, there's text, there's a variable, there's a loop. Let's see what we have there. Yeah, that's very simple. In most programming environment, you would have a while loop, a repeat, or a for. They pretty much do the same thing, and you iterate the same process again and again until you are happy. All right, and let's drag this here. We are going to repeat a certain process. Repeat what? Repeat this. Make a cube and rotate it. Make a cube and rotate it. So, how many times? See, that's the index I think that's why. You can change it to any other name if you like. I is the index, is a counter. It counts how many times. We're going from 1 to 360. How about that? And how do we go from 1 to 360? Let's go up. We increment 20 degrees. Okay, the how is the overall shape. Leave it alone for the moment. So this purple block really iterates this blue one inside, the fancy rotate, right? So now, just now we have 60 degrees here, but this time we are going to allow the variable, the counter, to specify the amount of rotation. So we are going to find I. See, we kind of drag I directly here. Let's see how and where we can find the variable I. It is here. Click variable, the variable section block, and find the name I. You can create new variables if you like. So let's drag this to here and put it here. All right, does that make sense? So we're going to repeat this process many times, from 1 to 360. It's about 18 times, and every time we're going to rotate, say 1 degree to 21 degrees, and it go up by 20, right? So let's see what happens. Make sense? 3 lines of code: cube, rotate, repeat. Let's render that part. Okay, change the color if you want to. If you work with the children, it's always good to play with the colors. How about the orange for this render? There we go. So we have 18, I would say 18 cubes here, overlapping space. If you really want to have a smooth surface, see that looks cool, right? It's a solid now. You can generate a STL code and then print it. Yeah. Yes, you can print it, and just print it using some slicing strategy, or I think you need to use a lot of support. All right, what if I want to make a smoother shape? So change the increment from 20 to 10, or even to 1 if you like. So this time we are going to have about, see, every 10 degrees we create a cube. Render that. That's a pretty smooth cube, right? All right, if you're ready to print this or save it as a file, look down or look around and find the command generate STL. It's going to ask you where you want to save it. All right. Oh, it doesn't even ask you. It's going to save it somewhere in a default location. Find it. Could be in the download folder on your computer. Find it and then slice it and play with it. All right, does that make sense? So there are numerous commands we have here, and math, variable, you can define your own functions, modules, you can do all sorts of transforms, very interesting, right? So you can do a lot of interesting things by programming. One last thing before I stop. It's always good to look at the codes behind the blocks and the solid. Click a code. How simple that is. We really have a for command here, right? For I is the index to go from 0 to 360. See, the increment is in the middle. Okay, that's 1 colon 10 colon. That's how Openscad defines a loop, an iteration. And then we are going to rotate this cube around this vector 50 50 50, right? That's a vector, and it's in brackets in Openscad. And A equals I. A is the amount of rotation in degrees. So I goes from 1 all the way to 360. Does that make sense? So it's a great way to introduce young children to the ideas of programming and solid modeling, if you like. All right, thank you for watching, and I hope you are going to give it a try. Bye.